So this video is going to show you some examples of some integration by parts. So I said in the first video, the first thing you always want to try when you see an integral that's got things multiplied in it is u sub. So if this was u sub, then my u would be 3x, my du would be a 3 dx, but that does not explain the x out front, so u sub is going to fail. I have an extra x in there. So the next thing I would try is integration by parts. And just as a reminder, you're integrating u dv, and that will give you uv minus the integral of v du. So what you need to identify is both a u and a dv. This represents your u dv. So my general rule is that your u will be a polynomial if you have one unless there's a natural log in the function, and you'll see why in the next example. So I'm going to try u is equal to x. That leaves everything else to be my dv. So dv equals e to the 3x dx. And you can see that I'm taking the integral of these two things multiplied. Well, if you look at what it's equaling over here, I need a v and I need a du. Well, du will be the derivative of my u, so it is 1 dx. My v will be the integral of the v, so that will be a 1/3 e to the 3x. And you can check that. The derivative of e to the 3x is e to the 3x times 3, because this is a u sub inside of an integration by parts problem. So your next step is actually just to write this out. So it will be u times v. So I'm doing x times 1/3, so I'll put the 3 here, e to the 3x, minus the integral of v du. So I have a 1/3 e to the 3x times 1 dx. That's just 1/3 e to the 3x dx. Now, this will work, our process will work if we can now integrate this, and that's what I said in the previous video. If you can't integrate this, then you've got more steps to take or figure something out. Well, if you look, this is now just a u sub problem. U equals 3x, so my du will be a 3 dx, and I don't have any extra x's anymore, so this is going to work out. So this will equal x over 3 e to the 3x, excuse me, and then I'm going to bring my 1/3 down, and then I'm going to integrate the e to the 3x, and when I do that, I'm going to get another 1/3 e to the 3x and put my plus c on. So this simplifies to x over 3 e to the 3x minus 1/9 e to the 3x plus c. And that problem is done. Things that people do, you could put the e to the 3x with the x in the numerator and put the e to the 3x over 9, but that is integration by parts. So the second example here, we have the integral of x to the 3rd natural log of x dx. So u sub, there's no way u sub is going to work here. So the next thing I do is identify what could my u be and what could my dv be. Well, I said that you should let u be a polynomial, be the polynomial, unless there's a natural log in the function. Well, here's my natural log right here. So I'm going to say my u is my natural log of x, and my dv will equal the x to the 3rd dx. Your next step is to determine du and v. Well, the derivative of the natural log of x is 1 over x dx. The integral of x to the 3rd dx is a 1/4 x to the 4th. So now I'll follow the pattern. It's u times v, so I have a 1/4 natural log of x times x to the 4th, and I would normally rewrite that, put that in front too, minus the integral of v, 1/4 x to the 4th du times a 1 over x dx. Remember that this has to be something you can take an integral of, and a lot of my students, when they look at this, are thinking, I can't do an integral of that, but you can simplify it. You have an x to the 4th over an x. So I'm going to rewrite all of this one more time. So I'm going to say it's 1/4 x to the fourth natural log of x minus the integral of 1/4 x to the third dx, because one of my x's canceled out. I can integrate this pretty easily. It's just the power rule. So my final answer will be 1/4 x to the fourth natural log of x minus, and I'm going to raise the power by 1, so there's an x to the fourth, divide by my new power, 1/16. So I'm dividing by a 4 plus c. And we have found the integral. We're going to work one more problem with this using this method, and then I'm going to show you a different method. So imagine that you have the integral of x squared e to the 3x. This doesn't work with u sub, so I'm going to identify my u and my dv. Well, there's no natural log in the problem, so I'm going to try u as my x squared. And my dv will be everything that's left. So e to the 3x dx. Your next step, find your du and your v. My du is 2x dx, and my v will be the integral of this, so 1/3 e to the 3x. Then I'm going to use my pattern. It's u times v, so I'm going to say this is a 1/3 x squared e to the 3x minus the integral of v du. So I now have a 2/3 x e to the 3x dx. So I'm supposed to be able to integrate this. But u sub still doesn't work. You'll see that I have an extra x sitting here again. That doesn't mean you can't do the problem. It just means that I'm going to get to do integration by parts one more time. So you can see that this could go on for a while. Imagine if that was an x to the fifth. Okay? So I'm going to again select a u and a dv just for this piece of the integral. So my u will be the polynomial. Let's call it 2/3 x. My dv will be everything else, which is an e to the 3x dx. Now I find my du, that is 2/3, and my v, which is 1/3 e to the 3x. And this is a dx here. So I know that this is, and I'm going to keep this in my problem because it's still there, it's a 1/3 x squared e to the 3x minus, open a set of parentheses, and then it's u times v, so I have a 2/3 times a 1/3, that's 2/9 x e to the 3x, minus the integral of v du. So I have a 1/3 times a 2/3 here, that's 2/9 e to the 3x dx. Well, this is now something I can actually integrate. It is a u sub problem. It's e to the u. So the integral of this will be 1/3 e to the 3x. So I'm going to write this out again. And I have a 1/3 x squared e to the 3x. I'm going to subtract 2/9 x e to the 3x. And then if you look at this, a negative times a negative is a plus. And then the integral of e to the 3x, again, is 1/3 e to the 3x. So I'm going to have a plus 2/27 e to the 3x plus c. And if I'd come up with something else I couldn't integrate, I had extra x's, I would have to do the process again. But what I want you to notice is that we have some signs changing here. Because if I had to do it again, I would be subtracting, and then there would be a set of parentheses, and the signs would change again. Look at your powers of x. X squared, x, no x at all. So we're taking derivatives of the x term, and we're integrating the other term each time. So on the next video, I'm going to show you a different method. It's the same exact process, but it's a different way to organize for integration by parts.